Okay, welcome back to some serious calculus here. Okay, number 6, given a curve, so this is an x and a y curve, right? It's not a function, but it is a curve. The first thing says find dy dx. Okay, so we're going to find the first derivative by using implicit differentiation. Okay, implicit differentiation. And this is going to take a little bit of space, so make sure you have some space here. We have xy to the second power minus x cubed y equals 6. Okay, so first of all, we have two things that are going to be product rule. Right? These are multiplying two functions together, an x function and a y function. So we're going to use the product rule to do both of these. So that product rule is the derivative of the first times the second plus the first times the derivative of the second, right? Where x is your first term and y is your second term, right? The g and the f. So anytime we see x, y together, you need to think product rule. So the derivative of x is 1 times y squared. Plus, then I have x times the derivative of y squared, which is 2y, times y prime, or dy dx, if you're so inclined to write it as dy dx. Minus all of this stuff. We're going to do the same thing. The derivative of x cubed is 3x squared times y, plus x cubed times the derivative of y, which is y prime. And that equals the derivative of 6, which is 0. Okay, so our job is to get all of the y prime stuff together on one side and get the non-y prime stuff on the other side. So I have a y squared, that doesn't have a y prime in it, minus 3x squared y. So both of these terms don't have y prime, so I get them together. Plus, here are some y prime terms. So 2xy y prime minus x cubed y prime, right? Those all have a y prime in them. So our next step would be to take all of my non-y prime stuff and subtract it to the other side of my equal sign. So this is a positive 3x squared y minus y squared. And then from here, I am going to factor out my y prime from each of these terms, leaving a 2xy minus x cubed as the leftovers. So now our last step in solving for y prime, which is also known as dy dx, by the way, is to divide both sides by the yellow stuff. So 3x squared y minus y squared, all divided by 2xy minus x cubed. Okay, let's go back and see what part B says. Find all the points on the curve whose x coordinate is 1. And then write the tangent line at each of these points. Okay, so when x is 1, we're going to use our original equation, right? Because a tangent line needs an x value, it needs a y value, and it needs a slope. And the slope comes from your derivative, but the x and the y come from your original function. So I'm going to plug 1 in for x up here in my original function. Okay, and I get basically 1 times y squared minus 1 times y equals 6. So I'm going to change this into a quadratic. Y squared minus y minus 6 equals 0, right? Because 1 cubed is 1 and 1 times y squared is 1. So I get y squared minus y minus 6 equals 0, which is a factorable polynomial. Okay, this factors to y minus 3 and y plus 2. Which means y has to be positive 3 or negative 2. So our 2 points are 1 comma 3 and 1 comma negative 2. So we're going to write equations of tangent lines for both of these points. Okay, so hopefully you're going to use point slope form. Y minus 3 equals m times x minus 1. Y plus 2 equals m times x minus 1. Okay, so what I'm missing is my slope. Okay, I'm missing the slope from both of these equations. But I know the slope. I calculated that below. That was my dy dx. So let's replace x with 1 and y with 3. So we're going to do this one at a time to get them both done correctly. So the slope of the tangent line at the point 1 comma 3 is 0. Okay, so basically the answer is y equals 3, right? Because if we were to multiply 0 into both of these, then it's y minus 3 equals 0. So the tangent line would be y equals 3. But leaving it like this is perfectly acceptable. You do not have to simplify it at all. Okay, let's do the same thing for our second point, 1 comma negative 2. So the slope of our second line, the tangent line at the point 1, negative 2, is going to be positive 2. Okay? Yes, there is a lot of work that goes into these problems that are implicit differentiation. Right? But usually you're only going to be asked one of these things at a time, not all of them at the same time. Because the last one says, find the x-coordinate of each point where the tangent line is vertical. So what do we know about vertical tangent lines? We know that the slope of a vertical line is undefined. Okay, and if we have a fraction, because our dy dx was a fraction, how do we get an undefined value from a fraction? How do we get an undefined value? If your denominator is 0. Okay, if your denominator is 0, our function is undefined. And if your numerator is 0, then our value is 0. Okay, so we're going to take our numerator and we're going to set it equal to 0, and we're going to see what we get. So let's solve this. Yes, it has a y in it, but let's see what happens. Both of these terms have a common x. Right, this one is 2xy, and that's x cubed, so let's factor out the x, leaving me 2y minus x squared, right, equals 0. So I'm going to once again use this product, the zero product property. So either the first term x equals 0, or our second multiplier equals 0. Okay, this is how we solve anything. We want to factor it and set each of your factors equal to 0. Okay, so the left side is done, but we can add x squared to both sides. Is to square root both sides. And don't forget that when you square root things, we get positive and negative values. Okay, so the one on the right here is a function of y. Right, so that one doesn't really give us much information, but we're just going to go with x equals 0. X equals 0 is the point where we're going to have a vertical tangent line. Okay, let's see what else we have. Number 7 says, write an equation of the tangent line to the graph of x cosine x at 0, 1. So they give you the x value, they give you the y value, you need to figure out what your slope is. Okay, your slope comes from your derivative. So what's the derivative of x plus cosine x? Well, the derivative of x is 1, and the derivative of cosine is negative sine. So we need to find the slope when x is 0. So we're going to plug a 0 in here, so y prime at 0 is 1 minus the sine of 0. And hopefully you know the sine of 0 is 0, so 1 minus 0 is just 1. Okay, so our graph has a slope of 1. So now, let's take the information that we have and write an equation of the tangent line. So y minus 1 equals 1 times x minus 0. Okay, and we notice that none of our answers are in that form. Right? None of our answers are in that form. So we want to solve this equation for y by adding 1 to the right side. So y equals x plus 1. And is that an option? Yes, it looks like that's option B. All right, number 8. What is the instantaneous rate of change? Okay, hopefully you know these words to mean derivative. So we're going to find the derivative of this rational function. Which one of our rules should we use? The quotient rule. It is a fraction. We're going to use the quotient rule to do this. Remember the quotient rule, low function times the derivative of the high function minus the high times the derivative of the low over the low function squared. Okay, so that's what we're going to do here is use the quotient rule to find the derivative. So that's your derivative. Now, you don't have to simplify this because it wants it to be evaluated at x equals 2. So you can plug 2 in for all the x's right now, and then you can get the number. So 2 minus 1, that's 1. 1 times 4 is 4. Minus 2 squared is 4. 4 minus 2 is 2. Over 2 minus 1 is 1. 1 squared is 1. 4 minus 2 is 2. Is that an option? Yes, yes it is. Option D. Okay, number 9. We're given a tangent function and asked to evaluate the derivative at the point pi over 6. Okay, so let's see what we get. This is number 9. F of x equals the tangent of 2x. And what's f prime at pi over 6? Okay, so let's take the derivative. What's the derivative of tan, right? This is something you should memorize. But the derivative of tan is secant squared of 2x times, what's the derivative of 2x? 2, right? It's always a chain rule derivative. So now let's evaluate at pi over 6. So 2 times the secant squared of 2 times pi over 6. Okay, so one thing at a time. What is the 2 times pi over 6? So now we need to evaluate using our unit circle. What is the secant at pi over 3? Okay, I'm not quite sure about secant, but I do know secant is the reciprocal of cosine. And the cosine at pi over 3 is 1/2. Because the coordinate there is 1/2 comma root 3 over 2. Okay, so I know the cosine at pi over 3 is 1/2. And I know the secant is the reciprocal of the cosine. So what's the reciprocal of 1/2? Positive 2. Okay, so that goes in here. The secant at pi over 3 is 2, and I still have to square that. Right, I am squaring the secant value. I'm not squaring the angle. So first I find the secant at pi over 3 is 2, and then I square that. 2 squared is 4. 4 times 2 is 8. Is that an option up above? Yes, it is. The answer is E8. Okay, here's number 11. We have an absolute value function. So let's remind you what's going on with an absolute value. Remember that graphs to a V, right? Negative x on the left, positive x on the right. Okay, so this is the graph of absolute value of x. So is it continuous at 0, right? Yes. Yes, it is. I do not have to pick up my pencil at all as I graph this. So continuity, yes. It's continuous. Is it differentiable? Right? The answer is no, because there is a cusp. Right? It makes a hard angular turn. And if we have an angular turn in our graph, that function is not differentiable at that angular turn. And then the third part here, does it have an absolute minimum? And that answer is yes also. Okay, 0 is the lowest that this graph is ever going to be. So the right answer is D. Our absolute value is continuous, and it has a minimum at 0, but it is not differentiable at 0 because there is a cusp there. All right, good. Number 12. This one's going to require us to talk about it for a minute. So buckle up, Buttercup, as we talk about this. Okay, G is a differentiable function. G is negative, right? So it's an always decreasing function. G is negative. That's important to understand that G is a negative values. All the y values of G are negative. Okay, so F is the derivative. We're taking the derivative of some function f, which is a quadratic, times g, right? Any of the y values from g. So our f prime, our derivative, is a product of two different things. So what is true? Well, we are talking about relative maximums and relative minimums. So we know that if f changes from an increasing function to a decreasing function, that means we have a maximum value, right? If our function changes from increasing to decreasing, we have a maximum. So that means that f prime had to change from positive to negative. Okay, so we're going to do a little sign analysis of f prime. Okay, so what do we know? We know that f prime is equal to some function x squared minus 4 times a negative value. Okay, so it's f is x squared minus 4 times a negative. So let's see where that is positive or negative. So if we were to solve this part, right, x squared minus 4 equals 0, we get negative 2 and positive 2 as your critical values. Okay, so let's test some values. What if I had negative 3? Okay, if I plug negative 3 into here, that's positive 9. Positive 9 minus 4 is 5. So this is 5 times a negative value, which means we're going to have a negative number to the left of negative 2. Okay, what if I plugged in 0? That's a negative 4 times a negative number. Negative 4 times a negative number is going to be a positive in between there and there. Okay, and what if I plugged in positive 3? That's once again 9 minus 4, which is 5. 5 times a negative is going to be a negative. Okay, so let's look at our graph. We have decreasing function, and then we have increasing function, and then we have a decreasing function, which means at negative 2, we're going to have a relative minimum. And at positive 2, we're going to have a max. Okay, so a minimum at negative 2, because our derivative changes from negative to positive, and a maximum at positive 2, because our derivative sign changes from positive to negative. So let's see what option that is. Oh, that option is B, relative min at negative 2 and a relative max at positive 2. Okay, that one was some pretty intense things because we had to do a lot. I mean, it's just a lot, right? AP wants you to squish as many concepts into a single problem as possible. So hopefully this helps and your brain is better than it was yesterday.